In this video, I explain the confidence interval estimation of a population mean. How we calculate the formula of confidence interval for population mean. In case when population is normal and standard deviation is known. So consider a random sample x1, x2, x3, so on xn of size n drawn from normal population. The population under study is normal with unknown mean. Its mean mu is unknown because we want to calculate confidence interval for mean, and a non-standard deviation, but the standard deviation is known in this case. So if population is normal and standard deviation is known, and we draw a sample from normal population, so for this is the assumptions. So then the sampling distribution of mean x bar will be normal. If your population under study is normal, and from this normal population we draw different samples, suppose that we draw 10 samples, and mean of each sample x bar, we make its distribution, which is called sampling distribution of mean x bar. I explain detailed with my videos on sampling that are present on this channel, Statisticians Club. So then the sampling distribution of mean x bar will be normal with mean mu and standard deviation sigma. So remember that, I again repeat, if your population is normal, under study population is normal with non-standard deviation, and you draw samples, and sampling distribution of mean will also be normal and with standard deviation sigma. Then the sampling distribution of mean x bar will be normal with mean mu and standard error. Here is mistaken, standard error, sigma over under root n. Its standard error will be sigma over under root n. The variable z is equal to x bar minus mu over standard error. As you know, standard error is the deviation among the samples of sampling distributions about mean. So will be exactly standard normal no matter how small the sample size will be. When standard deviation is known, there is no matter what is the sample size. So it means it follows the normal distribution. But if the standard deviation unknown, then sample size matter. But we study this case in my next videos. So the normal distribution tells us that the probability that value z fall within the interval minus z alpha by 2 to plus z alpha by 2, and this is equal to 1 minus alpha. This 1 minus alpha is the confidence limit, and alpha is the level of significance. For example, if you suppose your level of significance is 10%, so 1 minus 10% means 0.10 is equal to 90%. So your confidence interval will be 90%. You calculate this within 90% confidence interval. So z alpha by 2 is equal to alpha by 2. That is, we can make the following probability statement. So this is our probability statement, probability of minus z alpha by 2. And here is the formula of standardized variable, which is x bar minus mean, because we calculate confidence interval for mean. So sample mean minus population mean over standard error of mean, which is sigma over under root n. Z is equal to sample mean because this confidence interval about population mean. So sample mean minus population mean over z over standard error of mean, which is sigma over under root n. Z alpha by 2 is equal to 1 minus alpha, which is the confidence limit. So you can understand here this interval is 1 minus alpha. Here is alpha by 2. If your alpha is 10%, so 0.05 alpha by 2 here and 0.05 here, and 1 minus alpha 1 minus 0.10, because 10 divided by 100, 10 means 90% interval is here, and we are 90% sure our value of mean will lie within this range, and we have doubt 10% that mean calculated will lie in this range. So this is the meaning of confidence interval. Here is the figure. As you see, this is mean mu, and if we calculate minus 1 standard deviation and plus 1 standard deviation, 68% area covered. If we add 2 standard deviation and minus 2 standard deviation, 95% area covered. If we add 3 standard deviation and minus 3 standard deviation, 99.7% area will be covered. To put inside inequality within brackets, we proceed as minus z alpha by 2 sigma over under root 10 x bar minus mu z alpha by 2 sigma over under root 10. Standard error also multiply here, but there is mistaken. You can write here sigma over under root 10, because we multiply sigma over under root 10 with whole equations. So sigma over under root 10 multiply here minus z alpha by 2 sigma over under root 10. This term cut with this multiplicated term, and sigma over under root n also multiply with this term. So now subtracting x bar. When you subtract x bar minus z alpha by 2 sigma over under root 10, here minus x bar plus x bar cancel out, minus mu, and minus x bar plus z alpha by 2 sigma over under root 10. So multiply by minus 1. When you multiply by minus 1, this is x bar plus z alpha by 2 sigma over under root 10, and as you know, when you multiply with minus 1, inequalities change. So this is greater than mu, and this less also convert into greater than, minus multiply this term will be plus, and this minus this plus will be minus plus minus. So minus z alpha by 2 sigma over under root 10. So this is equivalent to x bar minus z alpha by 2 sigma over under root 10 less than mu less than x bar plus z alpha by 2 sigma over under root 10. We reverse the equation. We rewrite is because this term is less than, so we write here at start and change the inequality. X bar minus z alpha by 2 sigma over under root n less than mu less than x bar plus z alpha by 2 sigma over under root n. We substitute the result in the probability statement. So we substitute these results in the probability statement. So probability of x bar minus z alpha by 2 sigma over under root n less than mu less than x bar plus z alpha by 2 sigma over under root n is equal to 1 minus alpha. Hence, these are the formula for to calculate 100 into 1 minus alpha percent confidence interval mu, which is x bar plus minus. You can simplify it as x bar plus minus z alpha by 2 sigma over under root n. Because one time minus and one time plus, you can rewrite it as. So if you want to see videos about difference between estimate and estimator, what is confidence interval, what is statistical inference, then click the link in front of your screen. Thanks for watching.